Hello everyone, welcome back to Electro Logic. In this tutorial, we are going to create a simple water tank filling project using AVEVA InTouch HMI. This project is specially designed for beginners who are starting to learn HMI and SCADA. In this project, we will create a water tank, pump, valve, control switch, water level indication, and the required animation and scripting. We will complete the project in 5 main steps. First, we will create the HMI screen and arrange all the required objects. Second, we will create and configure the tags. Third, we will configure the water level animation. Fourth, we will add the required scripts and control logic. And finally, we will run the project in runtime mode and test the complete operation. So, let's start building our water tank filling HMI project step by step. First, open AVEVA InTouch window maker. Create a new application and give it a suitable name. After creating the application, open the window maker environment. Now we need to create a new window for our project. Let's create a window and name it Water Tank. This window will be our main HMI screen. Now we can start designing the screen. The first object we need is the water tank. Place the tank in the main working area. We can resize the tank according to our requirement and position it properly on the screen. Next, we need a pump. Place the pump on the left side of the tank. The pump will represent the device that supplies water to the tank. Now draw a pipe between the pump and the tank. We also need a valve in the water flow path. Place the valve between the pump and the tank. The valve will be used to control the water flow. Now we need an on and off control switch. Place the switch on the screen where it is easy for the operator to access. We can also add text labels for the pump, valve, tank, and control switch. This makes the HMI easier to understand. Now we need to create the water inside the tank. For this, create a rectangle or suitable shape inside the tank. Place the water object at the bottom of the tank. Make sure the water object fits properly inside the tank. This object will later be animated to show the actual water level. So, at this stage, our basic HMI layout is ready. We have the tank, pump, pipe, valve, control switch, and water object. Now let's move to the next step and configure the tags. Now we need to create the tags that will control our HMI objects. In InTouch, tags are used to store values and control different objects and animations. Open the tag name dictionary. Let's start with the main on and off control. Create a new tag named S1. Set its type to memory discrete. This tag will be used for our on and off switch. When the switch is off, S1 will have a value of 0. When the switch is on, S1 will have a value of 1. Now let's create the tags required for the pump and valve. Create the required pump control tag and set it as a memory discrete tag. This tag will control the pump indication. Next, create a memory discrete tag for the valve. We can use this tag to indicate whether the valve is on or off. Now we need the most important tag for this project. Create a tag named fill. For the water level, use a memory real tag. The fill tag will store the water level value. We will use a range from 0 to 100. So, when fill is 0, the tank will be empty. When fill is 50, the tank will be half full. And when fill reaches 100, the tank will be completely full. We can also create tags for the low level and high level sensors. These tags can later be used for automatic control. Now let's go back to the HMI screen. Select the on and off switch. Open its touch or animation link configuration. Assign the S1 tag to the switch. Now the switch is connected to our control tag. Next, select the pump and configure its animation link. Assign the pump control tag. This allows the pump to visually indicate its operating condition. Do the same for the valve. Assign the valve tag to its animation. Now the basic control objects are connected with their respective tags. The most important remaining task is to connect the water object with the fill tag. Let's do that in the next step. Now we will configure the water level animation. This is one of the most important parts of our project. Select the water object that we created inside the tank. Open the animation links. Here we need to configure the appropriate fill animation. The purpose of this animation is to change the height of the water according to the value of our fill tag. For the expression, select the fill tag. Now set the minimum value to 0. Set the maximum value to 100. Also make sure that the water fills in the correct direction, from bottom to top. Let's understand how this works. When the fill value is 0, the water object will show the empty condition. When the value increases, the height of the water will also increase. For example, at 25%, the tank will show approximately 1/4 water. At 50%, the tank will appear half full. At 75%, the water level will be near the top. And at 100%, the tank will be completely full. Now let's add a slider for testing the animation. Place the slider on the right side of the HMI screen. Configure the slider so that it works with the fill tag. Set the slider range from 0 to 100. Now we can test the water level manually. Move the slider from 0 toward 100. As the value changes, observe the water inside the tank. The water should move upward according to the fill value. Let's test it again. At 0, the tank is empty. Move it to 25. The water level increases. Move it to 50. Now the tank is approximately half full. Move it to 75. The water level rises further. And finally, move it to 100. Now the tank is completely full. This confirms that our water level animation is working correctly. The slider is mainly useful during development and testing. Once we add the actual control logic, the fill value can be changed automatically by the script. Now our visual animation is ready. Next, we will add the scripts that will control the complete operation. Now let's configure the window scripts. Scripts are used to control the behavior of our HMI project. First, we will configure the initial conditions. Open the window script configuration. Select the on-show condition. The on-show script runs when the window is open. Here, we can initialize our tags. For example, we can set the main switch to off. We can set the pump and valve to off. And we can set the initial water level to 0. This ensures that every time we open the HMI window, the project starts from a known condition. Now let's move to the main control logic. Select the while showing condition. This script continuously checks the conditions while the window is active. Here, we can check the status of the main on and off switch. When the operator turns the switch on, the filling operation should start. The pump can be turned on. The valve can also be opened. At the same time, the water level value can start increasing. So the basic sequence is, first, the operator turns on the switch. Then the pump starts. The valve opens. The fill value begins to increase. And the water level inside the tank gradually rises. Let's understand the water level logic. If the fill value is 0, the tank is empty. As the filling process continues, the fill value increases. For example, it can move from 10 to 20, then 30, 40, 50, and so on. The animation automatically converts this value into a visual water level. Now we also need a maximum limit. The water level should never increase above 100. Therefore, when the fill value reaches 100, we keep it at 100. At this point, we can stop the pump and close the valve. This represents the high-level condition. We can also use a high-level sensor for this purpose. Similarly, a low-level sensor can be used to detect when the tank reaches a low water level. These sensor signals can later be connected to automatic control logic. This makes the project more realistic and closer to an industrial HMI application. Now let's look at the complete sequence. When the switch is off, the filling operation remains stopped. When the switch is turned on, the pump starts and the valve opens. The water level begins increasing. The tank gradually fills. When the water reaches 100%, the filling process stops. This is the basic working principle of our water tank filling project. Now our HMI design, tags, animation, and basic control logic are ready. Let's move to the final step and test everything in runtime. Now it's time to test our complete project. Save the application first. Then run the project in runtime mode. When the HMI starts, check the initial condition. The tank should be empty. The pump should be off. The valve should be in the off or closed condition. And the main switch should also be off. Now turn on the main switch. Observe the pump indication. The pump should turn on. Now check the valve. The valve should also indicate the on or open condition. Next, observe the water inside the tank. The water level should start increasing according to the fill value. Let's test the water level. As the value increases from 0 to 50, the water should gradually rise. When the value reaches 100, the tank should show the full condition. Now turn the main switch off. The filling operation should stop. This confirms that the basic control logic is working. We can also use the slider during testing to manually change the fill value. Move the slider down and observe the water level. The water should decrease accordingly. Move the slider back toward 100. The water should rise again. This is a very useful way to verify the animation before connecting the HMI to a real PLC. At this point, our basic water tank filling HMI project is complete. We have created the HMI screen. We created and configured the required tags. We connected the pump, valve, and control switch. We created the water level animation from 0 to 100%. We configured the window scripts. And finally, we tested the complete project in runtime mode. This project is a simple but very useful starting point for learning AVEVA InTouch HMI and SCADA. You can further improve this project by adding automatic control, alarm indications, level sensors, pump status, start and stop buttons, and PLC communication. If you found this tutorial useful, please like the video, subscribe to the Electro Logic channel, and share your feedback or suggestions in the comment box. If you want me to cover any specific PLC, HMI, or SCADA topic in the next video, let me know in the comments. Thanks for watching. Keep learning, keep practicing, and I'll see you in the next tutorial.
वीडियोस बनाने हैं, फिल्मोरा है ना।